So just a reminder, these TA sessions will be occurring every Tuesday from 6 to 8. And mostly the idea is that I'll be covering some of the main important topics which will be taught in the NPTEL course. And mostly it's just for like covering those, yes, but it's mostly for you guys to, if you're facing any issues or doubts or something, then I can just clear those. So that's the purpose of these sessions. Um, yeah. Oh, short introduction. I am Gaurav, PhD student at CDS Department of Indian Institute of Science. C, the language C++, I've been using in my research for about 4 years now. So it's like basically we extensively use it in our research, right? So one useful thing is that knowing the modern features of this language is quite useful, as we'll keep seeing. Okay, hence the course. Okay, um, yeah. So that's sort of the motivation behind this learning this course. Okay, it's, I mean, as you guys know, C++ is being used in pretty much everything. Um, Other languages become sort of a wrapper for this. So if you're calling libraries like Glass or LAPACK or anything, pretty much those are written in C or C++, those things. So yeah. Again, some of them are written in Fortran also. So yeah, it's like certain languages still have their place. So it's basically when you want performance and scalability. So yeah. Okay. So I'll start. Last class I started with some basic topics, and slowly we'll move to the more advanced stuff. So just bear with me if you guys already know some of these things, just to recap, and so that people are on the same page. So I just covered some of them last class, and today I'll be covering something similar. It won't be too advanced, but we will jump to the advanced stuff very pretty soon, probably the next class. Yeah.
Hello, sir. I had a
Yeah,
doubt. This is
sure.
the first, like for week one, kahi, this is lecture, na?
This is week 2. So we had a class last week. So the lectures are available online. It's available on YouTube. You can contact NPTEL for all the links and everything, but I can just probably share it anyway. Let
Okay.
me just see. You
Thank you,
can
sir.
go. Yeah, sure. It's pretty, I would say, not very advanced, like the initial steps. So you can just go through them. It's not very uh, difficult, I would say. Thing is, uh, the advanced stuff will come later. So this is just to so that people are aware and all. So hence. This one, I'm not sure if this is shareable. Okay, let me see. Okay, I'll put a few things. Okay. All right. So this is the drive link to all the code. So I'll keep updating this as we go through each week. Okay. Each folder will have all the codes that I'll be discussing. So this is the code for that. Um, and last week's YouTube link I'll just put also. There'll basically be a playlist, and you can keep going through the each lecture, or basically not the lecture, it's mostly the sessions. So each session you can go through. Okay. And yeah, that I guess pretty much covers it. Yeah. Okay. Um, right. I guess I can just do a short recap of last class, and yeah, and then we can start today's session with other topics. Yeah. Okay. All right. Let's see. I hope everybody can see my screen. Okay.
Yes, sir.
Okay. Great. All right. So just a small recap of last class, last session, actually. So as usual, we'll start with a very simple hello world kind of a program. But bear with me. There are still little nuances that C++ offers. So we'll also go through them also, those things also. Okay. So the main file. Okay. So every C++ always starts with the function main. Okay. Um, its data type itself can be integer, or you can keep it void. If it's integer, then the idea is that when you return 0 or 1 or something, that's the error code that comes out, and then you can, depending on what error code your code gave, okay, you can decide how to proceed further. Okay, so that's the idea. So it usually means the code ran successfully and everything. So that's why we return 0. You can avoid this. You can not return anything also. That's absolutely fine. You can then change into void. Absolutely fine. Usually you would have seen main function, okay, taking arguments like arg and argc and all. So that's supposed to take arguments from the terminal when you are launching any code. Okay, so during those times, um, that's essentially the idea. Okay, but again, it's up to you. You can choose not to take give arguments. So usually we won't. So I'm just keeping it empty for now. Okay, so that's one. So we saw running this part of the code. Okay, just this line. So C out, hello world and endian. Oh, before that, in every C++ code, you have to have header files. Okay, so IO stream is the header file for input and output streams. Okay, so hence it's called IO in short. Uh, the essential idea is that this contains some functions, okay, which we'll call for basic input and output. So output as in whatever we want our code, okay, to, okay, so just remember everything is sort of, you can think everything with respect to the code or the execution of your code, okay. So from the code, anything which goes out, sort of the output, anything which goes in is sort of the input, okay. And okay. Yeah, so with respect to the code, we have outputs. So like to say hello world. So that's the output our code gives out. Okay. So you can think of your code as the sort of the reference point. Okay. And cout is the function which is defined under this header file, which we'll use to output anything from our code. So that's the standard cout, and standard endl is end of the line. Now, little more nuances. So why the standard? Cout, yes, is the function. Yes, main usually like functions like main, you have to have two brackets. Cout doesn't have it, but trust me, this is also a function. Okay, it's just not written in that form. Okay. Anyway, nonetheless, we'll look at this kind of functions later on. But the point is, this is a function, and these are the operators. Okay, this angular brackets operators, which take a stream of string. Okay, it's this whole string is a like you can think of it like characters. Okay, the string has collection of characters. It takes the whole string. The function takes it. Okay, and then outputs it to the terminal or the whatever display you have. Now, ENDL, cout is the That's the function of it. You can keep chaining it. Okay. You can have more and more like here. You can have strings with variables, so on and so forth. You can keep chaining. Okay. Yeah, that's the idea. Furthermore, we have at the end a ENDL line with a function, which is essentially a combination of a slash n and standard flush. Now, what are these? Slash n is essentially a new line. That's what the definition of when you put it within quotes and put slash n. It basically means a new line. Okay. So your terminal, let's say it comes uh, something like this, right? So this ls, what I wrote is one command, and then new line comes in. Okay. So that's sort of the idea. You have, for example, this is one line and this is the second line, so on and so forth. So that's the slash n command. Okay. So which tells the string that, oh, if you execute once this character string comes to slash n, you have to enter a new line. That's the essential idea. What's standard flush? Flush is the function which basically means uh, so essentially what happens is in using this kind of standard C out and C in and so forth and so on and so forth, you have something called buffers. Okay. So think of your computer, RAM or CPU cache, everything. So essentially they maintain a buffer for all this IO, okay, input and output. Now the thing is once it so can happen that you have all these character strings and everything, it goes into the buffer, stays there. Once that leaves the buffer, then it'll only actually see the output. Okay. So when you want to enforce your buffer to be clean and push to the actual terminal or the display, okay, that's when we use standard flush. Okay, that's the essential idea there. Okay. Oh, okay. That's I see. 29 July. Oh, um, hmm. Okay. I'm sorry about that. Maybe there was a miscommunication from NPTEL side. I'd informed them I'll start last week. Okay. In any case, okay. I'll sort of try to cover whatever I covered last as in this recap. So I hope you guys don't miss anything. Okay. And again, feel free to ask any questions or doubts if you have. Okay. All right. Yeah. So the standard flush essentially says that, look, CPU or computer, I want my buffer to be flushed out right now because I want all the strings or every input or everything, every stream of characters I have in my IO buffer. Okay. I want them to be printed. Okay. So that's why you use standard flush. So combination of both slash n and standard flush is your standard ENDL. Okay. That's the thing. I well, make and CMake are not part of this course. So no, we won't be covering that. But I think there is a tutorial lecture in for this course. Maybe that covers it. I'm not entirely sure, but I think it does. So you can go through that. But yeah, that's I understand it's a useful and it's a very important aspect of uh, coding in C++, using build tools. Yeah. Because for learning all these concepts, um, ours will be a very simple compiled. We use G++. Okay. You can feel free to use any of the other compilers available, Clang, MSVC, or Intel compilers, up to you, PGI compilers. Um, yeah, I'll just be using GCC, more specifically the G++ compiler. So yeah, that will take care of. Yeah. All right. Practice, honestly, it's difficult to say. You can probably find uh, code questions online. Essentially, it's like there is a lot of resources out there just for coding stuff. So yeah, I would suggest maybe do that. But what I would definitely ask you to focus on is because these concepts are little difficult to grasp at first. Okay, so maybe for the specific concept, try to do more and more questions, or maybe just go through the actual code whichever is taught in the lecture. Try commenting and uncommenting stuff to see how does one line behave. That's sort of the idea how I'll be also covering these topics. So you actually then understand how each of the line means. Okay, sort of like changes to certain part. How does it affect the other? Okay, all right. Something similar here, like that. Yeah. So that sort of covers slash n and standard flush. So that's standard E and D. Yeah, you can. Absolutely. You can use dev C++ also. The essential idea is you just need a compiler to compile all this code. One more thing you have to just be careful of while using any compiler. We will be using some modern features of C++. So your compiler should support it. Okay. Try to use sort of a latest or recent version of whatever compiler you want. So sometimes your compiler by default, let's say supports C++ 17 standard. Okay. So you do not need to specify it explicitly because by default it supports that till that standard. But if it doesn't, then you have to explicitly specify it. As in, let's say GCC version. This is again not. I don't know if it's true or not. I'm just giving an example. Let's say GCC 8 supports 17, but not by default. Okay. So you have to enable it specially. Like in while compiling it, you have to enable with a flag to tell the compiler that yes, I want to use these features and let me use like go ahead and use it. Essentially that. So you can feel free to use any compiler, but the point is understand the concept because that is not going to change. Okay. And second thing is while using some of the features, it might throw errors because if you don't use the supported compiler, then then anyway, you can't compile your code. So that's the thing. And the question is, you don't know C language, should I learn that side by side? Thing is, mm, C++ is sort of a superset of C, and it's like, how do I put it? You can choose to learn C on the side, yes, but the thing is, mm, I would suggest actually this course is a little assumes that you already know C++, okay, and then it moves on to the modern features. So there is that. Uh, the second thing I would say is you can learn C also, but if you don't know C or C++ either, and if you can manage time, sure, I would definitely recommend learning C. But if you don't know C++ or like either anyway, you will see that while trying to learn C++, a lot of the things are similar in C also, as in because C is the like it's C++ is sort of like C with some extra features. Okay, you can think that way. So yeah. Oh no, we're not covering DSA in this course. No, this is just programming in modern C++. You can find other like I think courses on NPTEL on DSA and other stuff. So yeah. Yeah, so that's a good question. If you don't clear, then what happens? Essentially, what happens is your buffer gets filled, and once it gets filled, then only it gets flushed out. Okay, so that's the default behavior. And sometimes it's not so apparent in these cases where you have a single threaded code. Okay, so but sometimes when you have multiple threaded codes or multi-process codes, so you actually want the buffer to be flushed out at that point. Let's say this line is being printed by different tasks. Okay, so sometimes what happens is a few of the tasks will not uh, push to the buffer. They push your output if their buffer is not clear. So you're sort of sometimes we want to enforce that. So in those cases, manually flushing it is required. Again, it's not always required to do it because yeah, well, it will flush it out because that's the code line. But again, when you wanted to enforce it, you use it. I hope that answers the question. C sharp. Oh, okay. Um, well, to be honest, I don't know about C sharp much though. Sorry. But what I would say is there is a structure to learning. I mean, C and C++ both, they have a certain structure and form in which they work. That's sort of what I'm trying to at least cover in some first two, or like maybe first 2 or 3 classes. You just have to get used to it, practice more. Again, that's what I advise. And yes, there are a lot of concepts which might be new or not familiar to many people. But then again, learning any new thing, there is only one way to do it. You just have to practice and get used to it. The main thing is once you get used to it, then things like this don't will feel second nature to you. Okay. Yeah. Okay. All right. Moving on. So another thing is, can anybody tell me this double angular brackets? What does it remind you of? As in, have you seen it anywhere used in C++? Okay. So that is actually the bitwise operator. You might have seen things like 8 and then shift, left shift to 2. So essentially it was used for, if, or you can use even like this, right? Okay, any of this double left angular brackets or double right angular brackets, either way, the idea is left or it's essentially means left shift or right shift operator bitwise. Okay. Now, thing is, we're sort of using the same operator here. Okay. The reason for that is this operator here deals with bits, right? Bits of the code. Um, 8 bits is 1 byte and so on. Those kind of bits. That is the idea. So this here, we'll learn overloading later, but that's what sort of happens here. So the bitwise operators here are overloaded to take in characters. Okay. So that stream of characters is what is input to the function. So that's sort of the idea here, to use this kind of operator. Okay. Next, yeah. Another thing we can do is write functions. So a simple function. Here's the question. Oh, that's the thing about C++. Ideally, when you're writing in C, so these data structures, right? Uh, like array lists, data structure, or maps or heaps, and so on. All these data structures can be implemented in C, C++, Python, every language. Now, in C, you do not have uh, this kind of well-defined structure there available to you. Okay. C++ gives you standard vector, which essentially is a list. Okay. And that data structure, you can represent your code. You use that in your code. Okay. And that's why it gives you standard vector, standard array, standard string, and so forth. So that's actually a useful thing about C++, which you can just take those classes and use it. Again, which data structure you use depends on a use case. So to understanding all these data structures and their counterparts in C++ is the main thing. You do not have to remember all of them, but there are some important ones which get regularly used. So you should know them about them. And as uh, you progress further, you learn about the other data structures as you go, as in when you require to use them. Okay. Okay. Hope that answers the question. And yeah, so coming back to functions. So yes, excuse me. Yeah. So we'll define a function called hello. I'll keep it void because I don't require any return type for it. Okay. And this function hello has a body enclosed by this curly braces. Okay. It just has standard cout, hello world, standard India. Okay. That's it. That's simple. Yes. Void is also a data type. So there are certain inbuilt data types in C++, C also. Um, Again, when I say things about C++, most of them are similar in C also. So yeah, inbuilt data types like integer, void. Void is actually like not a specific data, but again, it's like a zero data type, as in a null data type in a way. It doesn't, it just used to mean that there is no data type. In that sense, you can think like integer means like again, integer numbers. It represents integer numbers like 0, 1, 2, 3, or the negative numbers -1, -2, -3, so on. And there is a range to what integer means. So usually in modern systems, integer means 32-bit numbers, okay? And long integer will mean 64-bit integers. If you don't know about representation of numbers in computers, please do read it up. Representation of numbers in computers. So that's an important topic. How does there's so basically there's a IEEE standard which tells how integers get represented, both 32-bit, 64-bit, and so on and so forth. And there is another inbuilt data type which is called float or double. Float is the 32-bit part, and double is the 64-bit part for representing a decimal number. Okay. So fractions and negative fractions, so on and so forth, irrational numbers, anything. So all these other real numbers you can represent in your computer, and the differences between them is precision, how accurately you're representing. The trade-off being more data is required. Okay. What does void? It returns nothing. Actually, you can do this here also. So that's the thing about void. You can return and then close it. Absolutely okay. It returns nothing. You can think like void if you try to uh, think what it returns. It returns nothing, which in computer means null. The actual symbol is actually this with capital letters. Okay. So null is the return type in a way you can think, which basically means nothing. Okay. You can choose to return something as in have this line 12, or you can ignore it. Both are equivalent for this function. Okay. Or you can return null also. That's also fine. Sure. Actually, I'll be sharing all these lectures later in the file, the folder itself. So I'll upload all these codes. So let me just put up everything. It's probably processing or and all. Yeah, usually it is for processing. For calculations, we usually have data types. Yes, you can think that way. Yeah. Okay. Let's try to run this and see. For that, I should have the call to the function hello. Yes, which is under this namespace. Yeah. Let me just comment everything else. So, like you can see, I have this piece of code. Yeah. So G++, and I'm saying the output to be out. Okay, -o. And then I'm explicitly mentioning that I want to use C++17 features. Okay. Uh, it may not be required in your case. I'm just showcasing it anyway, so that some of the compilers where it's not enabled by default, so you have to specify it. So hence I'm showcasing. Then you give the file name. Okay. And this is for the terminal. I'm just chaining it again. So, and after this is done, I'm saying execute dot slash out. Okay. So running this, compilation done. So this line is basically the compilation, and this is the run. Okay. So running this, it prints hello world. Okay. It returns this, and basically this is the whole code. I've commented everything else. Okay. Yeah. It creates integer array and then calls hello. Okay. I'll come to the namespaces now. Yes. This is clear, I guess, so far. So return, let's say, I think this should work. Let's see. Yeah, null is not have a return value. Yeah. So you can choose to return nothing or not have this line at all. Both will work. Yeah. So that's hello world. Okay. Now, so this was just a simple function I used to call. Maybe just keep it simple for a bit. Yeah, coming to that. Again, that's the namespace is what I'm going to cover now. So I'm coming to that question. Yes. So imagine I don't have all this. Okay, just a simple hello world. So that's what we saw before. Hello world gets called. I have main function, and let me comment this also. So you just have integer main. One more thing, important thing about C++, alignment. Okay, doesn't matter. C++ doesn't care. You can have all this code inside in one line. That's absolutely okay. So you can actually write something like, I think I wrote it last time. Yeah, maybe not, but anyway, it's fine. Okay, you might have seen loops. Okay, so you can actually write the whole loop like this. This is perfectly valid code. Okay, the point being, um, once you put things inside curly braces, okay, if the syntax is correct, compiler will take care of it, like compiling to the actual binary. Fine. So that's the idea here. So alignment doesn't matter, but you should be careful with where your curly braces open and end. Okay. So here initially I'm declaring a variable a, which does nothing. So you can comment that also. It won't affect anything. But anyway, just to show. So we have a function hello. We call it by here. It doesn't take any input, so we're not passing anything, and just end it with semicolon. This is the function that gets called. Okay. Now, uh, which function? No. So the thing is, this is the declaration of that function. So main is my actual function that gets called first. And inside main, I have this hello function, which gets called, whose definition and declaration and definition both. The definition will be with the body, and its declaration is here itself. It's line 20. So the whole body and everything is here. Okay. So that is just saying this function exists. And if my program wants to call this, go ahead, just call this, I'll run this line. So that's what this function, this part of the code does. Ignore everything else. There is a header file, yes. After that, I just have this code and then main function. Okay. I hope that is clear, because this having this hello world doesn't mean anything, because it won't get executed unless it is called from the main function. Okay. Right. Now let's come to something in like very important concept. That's the namespace. So coming back to the same, yeah, this one. Coming back to the same one. I have couts and endls. Okay, but you might ask, what is this std colon colon? So this is a namespace. Namespace is basically a name given to a collection of things in C++. what are these things? Okay, I'm using air quotes. This can be functions. Okay, so like we have here. So this is a custom namespace I just made. Okay, I have functions like cout, hello, add, anything. You can have anything in your namespace. So to define a namespace, one uses something like this. You call namespace, give the name to your namespace. I just call it custom namespace. Okay, and then using that, you just use curly braces to enclose your namespace. You can have functions, variables, structs. You can have like classes, like anything. So the idea is that a collection of these things is named something under something. Okay, that something is the namespace. It's very useful. By using void, then why to use a term? Yeah, it's not like you need to use it. It's just that if you choose, you can. That's the thing. Both are syntactically same. That's the idea. If you want to use return, feel free. If you want to ignore it, also absolutely okay. Because when return happens, it returns the function as it ends the function. If you don't have it also, it ends the function anyway. So the effect is the same. Okay. For functions with type as void. Okay. Now something similar like this code. Okay. Namespace. We have some for standard. So the standard template library. Okay. So it's like a collection of library um, that comes with your C++. Like any C++ compiler which supports the standard C++ has this library, or it's called the STL. It's the standard template library. Now, the library has all its functions under this namespace, something called the standard std. Then how do you access it? You have to give the standard namespace with double colon, like colon, double colons. Okay. That tells it to use cout from this namespace, like which is defined in the standard, and it is available inside this header file. You can think of it like you can actually go to IOStream, okay, and check it out. So basically, it will be written something like this with namespace standard, okay, and then all this cout and then endl, all these functions will be defined there. Okay. Now, why to have namespaces? Like another example I'll give is, let me define a cout function in my custom namespace. What it does is it has cout, it prints hello world and ends. That's it. Yes, there is a function hello, which does the same thing, but ignore it for now. What was the point I'm getting at is, let me have a cout inside custom namespace. Okay. And now standard cout is also exists. Okay. So see, if let's say I call cout and don't give the namespace, what do you think will happen? Let's say I want to do this. Okay, let me just go this way. Let me keep the endl for line for now, because anyway, I've not defined it anywhere. Let's say I do this. What do you guys think will happen? Compiler gets confused which cout to call. It won't print because it doesn't know which cout to print. Okay, let's always just you can check things by compiling. So it says undeclared identifier. The reason for that is it doesn't know which cout to actually print, as in call. Is it the defined inside the standard or the one that I did? I had. So I can do this. I have not done the overloading of better, but the point is this line won't compile. Yes, as you can see, and won't work. Yeah, okay. So I can do something like this. So I'll use cout. Let's say the one that I defined. Okay, I defined here. Okay, so I have to give its custom namespace. And cout here is the function I'm calling inside the custom namespace, okay, in line 36, and which calls this function, which calls the standard cout, which is inside the standard template library, and that calls and that prints the hello world. I hope you appreciate the chain of how functions get called. Okay, this is essentially what happens in like literally every C++ code. You start with the main, then go to the next one, then go to the next one. And this function itself, so hello gets called from this hello. It calls the line 20 to 23, not the hello inside custom namespace. Okay, because I did not give custom namespace. All right. So I can probably tell um, call it outside. Okay. And this hello world as inside namespace. So because this function is there and this function is there. Okay. Let's compile and see. So the first main calls this hello. Okay, which prints outside. That's what we see. Then custom namespace hello gets called, which calls this function, which is namespace. That's what gets printed. And then custom namespace cout gets called, which prints hello. Simple. Which again calls standard cout from standard tuple library. And then finally, it returns back here to the next line. And then we see nothing. All these are commented lines. So return 0. Okay. I hope the idea is clear. If you have any questions, you can ask. But this is essentially how a typical C++ program looks like. Okay. And the important concept here is that we use namespaces to specify which function we want to call. Okay. Now I come back to the question which was asked using namespace standard. So now when you use namespace standard, okay, you can do this. Yes. But I'll come to that why it is not actually usually recommended. So if it doesn't find cout, like I have hello here, I don't need to specify anything namespace because it knows that we'll call this function. Okay, but cout is not defined in this file. It is defined in another namespace, which we are saying that use namespaces standard for the rest of the code. Okay, so it will find now this couts and print hello world again. Okay, hello world standard. Then let's call that. Okay. So that's what it prints. Okay. Now, yes, you can get away with using namespace standard, but it is not recommended because when I use cout here, just cout, I'm not telling to the programmer what is the actual function being used. Is it the one from namespace, like custom namespace or the standard namespace? Clarity sometimes gets lost and bugs get introduced. So in general practice, using namespace standard is not actually recommended, especially when you're working with very large code bases. Okay. So people usually avoid this. Yes, the downside to that is obviously your code uh, becomes longer with like namespace words and everything. But that's okay because readability takes precedence. So always readability, maintainability takes precedence over everything. You're not losing performance here. Don't worry. C++ will take care of that. So it's just that extra code to look at. Absolutely yes. But in terms of maintenance and so on and so forth, namespaces are usually highly recommended to have. Okay. So that's just good practice. Okay. Now coming to the question. I use custom namespace. Do I need to type? You don't need to type. You can type both. So the answer to that question with do I need to type custom namespace add 57 or just add? You can use both. Okay. As in, if you use custom, if you're saying using namespace standard, you don't need to specify that namespace explicitly. Okay. But if you want, you can do that. Yeah. Why we need it, but we can make function and call. Why should we custom namespace? Oh, yeah. You can put functions just purely like this. Yes. But sometimes to keep things clean and not have name collisions. Okay. So let's say I defined a function called cout that will have name collision with maybe some other function. Oh, I don't know, standard cout. Okay. So to have cout in my use case, I can just put all of them inside some namespace. That will be my namespace. Because you have to understand when a code is written, sometimes it gets part of a library and you call libraries. Okay. You do not want things to mix and match. Right. So you don't want to have the same function name. Maybe it is used in some other library. You are also using it. Then your compiler gets confused what to do. So it's just a good, clean practice to have namespaces for your part of the code so that when you are calling things, they're part of your namespace. And when you're calling another library like this, like the standard library, it has its own namespace. It's just good practice. You can get away with it for now because you're just learning and for assignments and all. But this is what people do in general in development. Okay, I hope that clears the question. Um, yeah. Another important thing is about scope. So remember, whenever you see two curly braces, that's a scope. Now, what does that mean? So for this function, this curly braces are a scope, as in anything that exists or gets declared on it inside it, its lifetime is only between these two guys. What does that mean? So, for example, I just define two. This is just an empty scope. Okay. Uh, so this piece of code I can just write without this. So let's say this did not exist. It's absolutely valid. So this piece of code gets executed, then this piece, and so on and so forth. But let's say I have this extra empty scope line. Now what I'm saying is these functions are inside this scope. For normal functions, it doesn't make a difference, okay? Because once this scope gets executed, anyway, it will go to the next line only, like line 36. But I have this variable a, okay? Let's say I try to print it. What do you guys think will happen? It will throw an error, okay? The reason being, a is not defined for this scope. So a's existence is only between this scope, the line 28 to 32. It gets declared, and then just when it reaches this line or it becomes out of scope, your compiler just says, oh, I'll deallocate it or destroy it or whatever. This is a very important concept in C++, the concept of scope, which will come later as we'll see in classes of constructors and destructors, uh, especially smart pointers. They make very heavy use of it. So the point being, I hope you understand the idea behind scope. Okay. So for the main function, this is the whole thing is the scope. So on and so forth. That's the idea. Question? Why we need it, but we can make function with call why should we use it? Oh, yeah, I think I answered that. Okay. Can't we use built-in standard namespace like using S plus standard rather than custom? You can, you can, but that's the thing. If you use using namespace standard, that means you're going to use functions from standard template library. If you are saying that I want to use using namespace standard, using namespace custom namespace, then you will be using the one that you define. That's it. There's no uh, difference there. As in, it depends on a use case. What do you want to do? That's all. Oh, the difference being that which namespace you're using to Dhruv. Answer to Dhruv, depending on whichever namespace you want to use, you just put that name. So let's say you do namespace standard. So you when you call functions, they will be called from this standard, from this namespace. If I use custom namespace, then if I don't specify the complete namespace and call some function hello or cout, then the cout will be called from custom namespace. That's it. It depends which namespace you are using, which function is more specifically which function you want to use. It depends on that. In general, avoid using this. Okay, no confusion. Give the full namespace. Put cout. Put your function name. Everything. Put everything explicitly. That's it. That's the best way. Yes, the priority order is always top to down, like top then to bottom.
So the first thing happens is compiler sees this custom namespace. Okay, it knows that this namespace exists in my code with the function names couts, hello, add, and so on. Then it sees that there is a hello separately. Okay, with not in any namespace. Okay, then it says main, and when it executes, it will always first execute main. Always remember, it has to start with main. Now it enters its scope. It says this scope, so it will go line by line. It will execute this. The whole thing gets done. So it will now move to this line 34, so on and so forth. Keeps going. Just so happens that hello gets executed, so it will call this function. Custom namespace hello gets executed, so it will call this function. Standard cout gets executed, so it will call the function defined inside the header library. Okay, as in it's defined there. Think of it like it's the code exists there. Okay, not entirely true, but anyway, for the sake of understanding, imagine that the code exists inside the header file. That gets executed. Again, endl gets executed. Now cout from custom namespace gets executed, and then the next line. Okay. Uh, yeah. To install C++, like to compile it in with VS Code also, you need to have some kind of C++ compiler. Just install GCC. You can look up online how to install GCC or any other compiler, and you can then use that from VS Code itself. Just it's just a Google search away. You can try that. Yeah, yeah. You can use MinW. Yeah, that's also okay. Right. Um, just a second. Next question. Which way is good learning CPP by practical question doing projects and from higher person doing project? You can do projects and learn. Yes. Again, depends how one chooses to learn. I would say try both. See if you actually feel that learning from project is better, then yes, you can do that also. Uh, Practice questions initially, yes, but I would say think of it this way. C++ itself has a lot of topics. Okay. Now, to learn each of the topic, you have to code it. Now, how do you want to code? If you want to learn, just, is your purpose learning C++ in general to build stuff, or you want to learn certain features? So let's say you want to learn lambda functions. To learn lambda function, you have to write code which uses lambda function. Okay. So you have now two choices. You can do just write a specific code for that and learn, which like as I'm showing you now this way, or you can build projects. Again, up to you. You can take a call however you like. Okay. Uh, this is a question. Is it a standard style library or library? So how is it different from IOStream? Oh no, that's the thing. IOStream is again okay. Here, when we say include something, it itself is a file. Okay. So what I can do here is this is absolutely okay. Now you might see this vector.cpp is another file inside. Okay, I can't use this actually. I have to write it this way. Okay. So the point being, if I want to include files in my current file, I have to include them using this line. Angular bracket just means that they're in path. Okay, there's a thing called path in Linux, Windows, and other OSs. It will look in that path, find the file, include it. These are called header files. This one doesn't have an extension, or it's not. It doesn't end with .h or anything. Again, that is also absolutely okay. You don't have to have extensions. Again, that's a separate topic altogether. But the point being, if you want to include files, you do it this way. I can even include the file that I have not even talked about, the vector.cpp file inside this. You can do that. As in, that's the sort of the idea. Yes, it will have some collisions. Like you see, you're including IOStream twice. Okay. Again, you don't have to worry. That is taken care of by the standard tuple library. It is written such that you you won't be able to include it more than once. Again, that should throw error. Okay, but it won't. So that's the idea there. Yes, that's the answer to the question. Uh, uh, how do you know if it's a standard tuple library or the standard? Yeah. Okay, how C++ code works. Okay, just before that, other questions? Which is okay, when you start using namespace standard, okay, that I think is the continuing question. Can you use the same variable for multiple time in the same code with different cases? Yes, you can. So Nandita, the answer is yes. You can use the same variable, but you cannot change its type. Because C++ is a strongly typed language, once you have defined A, you have to define its data type also. Let's say integer, you can reuse it. So now A can store integers, right? So let's say it stores 0 sometime. In other parts of the code, it will be 5 or 10 or something. You can reuse it, yes, but you can't change its type. You can't change call A now to be like float or something. It cannot, it just can't. Again, you can try to force store a float inside integer inside A. We'll look at typecasting later, but then end result is still the same. It will only store integer. It will treat that float as integer and then store it. Okay. So hope that answers the question. Okay, MingW, yes, should be able to install that and use. Yes. Again, how is it different from IOStream? Yeah. So IOStream again, to repeat, IOStream is sorry. Yeah, IOStream is the file which contains standard cout, standard ENDL, and so on and so forth. So a collection of standard template library functions have been written inside IOStream. Similarly, inside standard vector, the vector functions are written. So standard vector, so this is a class actually, a templated class. So standard vector is written is all these definitions and function everything. So yeah, you can see it here. So it is the class with allocator. This will look little daunting for now, but just so know that standard vector is defined inside standard vector library. So you have to include vector header file to use standard vectors. We'll come to that now. And that is one. Yeah, you can to use couts and ENDL and cins and so on, you have to include IOStream. Okay, this definition, essentially what I can then do is put all of this. Okay, and make a header file. Put all of this, include the header file. Okay, generally, the definition is not included in header files. Again, it's a convention. Up to you how you want to follow it. You can put the body itself inside the header file or not. Absolutely okay. But the point being, I can't use this. Yeah, you have to do it before. Oh, small difference. You have to use quotations if it is not in the path. Okay. And you want your include file to look first in the current folder. So you have to use the quotations. And if it's in the path, then you can use angular brackets. Usually, this is the convention and people follow in practice. Only use angular brackets for STL like libraries. Any user defined libraries or header files you include using quotations. Okay, I think this should work. Let's see. Oh, not others. Yes, A should not be there, of course. Very important thing. Compiler is the best friend. So it will throw errors. Yes, a lot of times it will shout at you. But if you go patiently, line by line, it will exactly tell you where the error is. Okay. So you can actually debug your code, at least compilation code parts very easily using the just learning how to look at error codes. Okay, so main function redefinition is happening because yeah, this is fine. Ah, because vector.cpp has a main function. So for now, I'll just ignore it. Okay, you have to remove the vector, its main function here. Okay, to include, but the idea is that you can still include even a CPP file inside a CPP file. Sort of, you can do that. Okay, great. I was able to move all the code that I wrote into its own header file. Okay, so the file was hello.cpp. I made another header file, moved all the code here. This part is the namespace part, and this part is the hello part, like just the plain function. Including that, because I included it here, I can call it inside my main function, main file also. Okay. So IOStream sort of looks very similar to this hello dot, where it has its own cout, own hello, own cout, endl, and so on and so forth. Okay. All right. Uh, Next question. How C++ works? Okay, that's a very good question. I'll come to that. Can I use Dev? Yes, you can use Dev C++. You can download VS Code with MingW and then use it. And download VS Code, unable to compile, how to get terminal. Oh, just it depends on the operating system you're using. If you're in Windows, you can try CMD or command prompt. If you are in Mac, don't open terminal, just search for terminal. Similar with Linux. Yeah. CO I don't know what that header file does, but you can always Google it. And a very good reference for all these references is CPP reference itself. Okay. You can always refer to all these functions and their definition, basically the documentation. It's a very good resource. So please follow that. I'm sure you can find the header file also, Anushri. Okay, that's as Dhruv has suggested. You can, so when you install MingW, it becomes sort of like a separate software and gets added to the path of your OS. You're using MingW, I'm guessing you're using Windows. So in Windows, um, I don't think G++ or GC comes by default. So you have to install something like MingW. So it gets added to the path. So essentially, G++ is also a compiled binary. I guess it's the right time to talk about how C++ works. Okay. So what I did here is I used G++, okay, to compile my code called hello.cpp and then executed the binary. So this binary is the compiled code of this thing. Okay, the hello.cpp. Now, G++ itself is also a binary. I know, sounds a little roundabout, but that's how it has been done. The C++ compiler itself is also written in C. The C compiler is written in C. So this is the compiled binary. Now think of it this way. The dot out is your G++. It takes inputs, okay, and the file itself and compiles, it gives another output. Sort of recursive way, but that's how it works. You compile things using the compiler, okay, to get your output. And that compiled binary is the compiler that you're using. So when you install MingW, it includes this compiled binary. Okay. It just think of it like a set of instructions. Okay. It includes in something called the path, and the path is like cattle PATH. Okay, path. So it's in your environment. Anything which exists in the path can be accessed from anywhere. That's the idea. So MingW includes GCC compiler, let's say for example G++, so that you don't need to specify the complete path. So for example, I do not need to give full name here and then uh, oh, sorry. I can do this also, but then again, it's not necessary because hello.cpp is I'm inside the folder here, but one can actually give the full name. Okay, you sort of don't have to do that for G++ also. So This is representative. You might have it in some user local bin or something. You can give the sorry. Okay. Ignore the suggestions. But the point is you can give the full path name and then pass all the argument variables and give the full path name to your code also and then execute. Okay. But if your MingW is properly installed, okay, it gets added to the path and you can choose. Is there a question? Okay. You can choose just to call G++ because it's included in the path. Your terminal knows which G++. Is there a question? All right. So the point is, if you have MingW installed in correct path, you can just call it from anywhere. Okay. I hope that sort of clears how simple MingW works. Okay. I hope the chat clears things. Which yeah, exam pattern and everything. I would suggest use the forum. So another thing, there is a C++ forum. I will probably put the links. It should be there in the um, NPTEL course website, but I'll also put it here. Um, you can join the course page or the Google group actually for discussions and everything. Okay. Exam related questions only they can take. Because I'm not the one who sets questions. I have no idea. I do not even correct your assignments. So sorry, I can't tell you how the pattern will be and everything. You can redirect your questions there. I put the Google Groups page. You can join that, ask questions related to exams and other concerns you have. Okay. Another question. Yeah. Using which terminal or how to run codes and such. You have to just play around with that or just watch a YouTube video how to run simple C++ code in VS Code. If you want to take VS Code as the ID or place you want to run C++. Okay. Yeah. Assignment questions. If you have doubts, I can't directly give you the solutions. But if you have any questions on the topics that you don't understand, you can always ask. I'll try to clarify them. That's directed towards Chinmay. Chinmay, sorry. Okay. Yeah, you can even use extensions. Feel free to look around. There are multiple ways you can run C++ codes. Okay. Depends um, heavily on the operating system, on the IDE you're using, the integrated development environment like VS Code or such. VS Code, well, is not exactly IDE, but again, you can sort of in between try to use it. Printing and streaming, what's the difference? Okay, there's a question. Feel free to ask. Somebody raised a hand. Yeah, go ahead.
Sir, I missed initially. You have used G++ minus O out, and then there is an ampersand with dot slash out. Why
Yes.
this ampersand was used?
Okay, so basically I could do this way. So this line compiles the code. Okay. Now to run the code,
Yeah.
I'll do this. I just
Yeah.
combine those two lines into one.
Okay. So
Yeah.
ampersand is combining.
Yeah. So that's a feature of actually the what do you call this? The shell you're using. So I'm here
Okay.
using Z shell. It comes with Mac, but in Bash or let's say you're using Linux. In bash also same command works. So double ampersand basically combines multiple lines.
Okay.
When the first thing gets executed, then only it moves to the next one and so forth.
Okay. Yeah. Thank you.
Any other questions? I saw some raised hands. Feel free to unmute yourself and ask. Yeah, in the meantime, I can probably tell then difference between printing and streaming. So printing is actually a sort of streaming. So when we say print, that is the output stream specifically. So stream itself is it can be both input or output stream. Okay, that's the idea. We will look at IO more clearly in much later uh, sessions. But the idea being, yes, streaming is the sort of the superset. Printing is one of them. Uh, Question: why compiled binaries are different for different OS? Like for .o extension, but yes, absolutely. Dot out. Yeah, since binaries are 0 and yes, absolutely. So think of it this way. Uh, I would rather clarify something there. Extensions don't mean anything. I know, sounds crazy, right? So here, if you see, I chose my compiled binary to have the name just out. If you see here, it prints just out. I can do it this way also. Well, let me just write it. Absolutely okay. I just changed something from out to hello dot. Wait, yes, here it is. Hello dot out. So yeah, something which was a name became an extension. How did that happen? Honestly, extensions don't mean anything. It's just a convenient way to separate files. Okay. At least in Windows, it makes a lot like Windows will shout at you. Yes, but in Linux, I'm not sure, maybe in Mac also, maybe. But in Linux, extensions don't mean anything. It's all about how the file type is. Because it says, so VS Code here with my extension, okay, extensions installed like this, okay. Um, sorry, yeah, extension installed with the C++ pack. You can use VS Code with C++ pack. It has some nice features. Again, just a suggestion, you can go ahead and play around with it. And yeah, so because of that, it sees .h file and assumes that this is a C header file and shows you this color. The CPP, it shows you this color. It's just for distinguishing and keeping things clean. Okay. Now, coming back to the question, why do we have different compilers? Now imagine this, you are including a header file, okay? And that header file is simple here. It's the standard template library. Okay. But this header file comes from the compiler that you're using for this system. Okay. Let's say you include header files, .h files, which includes a very OS specific function that exists only in that OS. Then your binary is compiled only for that OS because we included functions which are only defined in that OS. This is sort of the reason you sometimes can't use the same binary in different OS. Okay, but most of the time you can. Let's say this file. Okay, I made this binary out or hello.out, right? This you can use everywhere. You can use it in Mac, Linux, or anything because this .h, which I've included, is just plain old C++ file, nothing specific to OS. I even have, sorry, I even have IO stream, which will be defined like with all the headers and everything for that OS's um, standard type library. But because if you think about it, each OS can have its own way of handling things. Let's say C out. Okay. Maybe the binary that the compiler, sorry, the C++ compiler used in C, Mac or Linux or something, that will try to interface differently, maybe. So unless you have very OS specific codes, you can always use the same binary in different places. Again, this is not always true. Because again, I'll come back to the question with how C++ works. Okay, there is subtle nuances there, but yes, for static compiled libraries, you can. I'll come to what static and dynamic are. Okay, so more questions. Can you run more than one programming language in same VS Code? Not in the same window. I mean, it's like when you're running terminal. Okay, so here I'm using VS Code with terminal to compile this piece of code. If I have a Python file, I can compile that also. I mean, essentially here the terminal is, if I do PWD, I'm at this path. Okay. So whatever code exists in this path, I can compile and run. That's sort of the idea. Okay. Yeah, you can install different languages. Feel free to use explore VS Code itself. If you are not familiar with it, there are different extensions, and yes, there are some very useful suggestions in the chat also. Feel free to explore. But the point or the idea is uh, do learn C++ through practice, and the more you get used to it, more the advanced stuff will get easier. Okay. Yes. Coming little more explanation on that. So first of all, how C++ works, or any compiler actually. So what happens is I define a hello.out or some binary, right? And I'm giving all these flags. Use C++17. This is the file you have to compile, and then you're running it. Great. So first of all, your compiler G sees the whole file. Okay. Oh, this is my file I'm compiling. Okay. First, so always remember top to bottom. So first it says iostream include. So what it will do is there is a file called iostream. It will copy the whole thing, paste it here. Simply, it won't think about anything. Just blindly copy paste. Great, done. Next line. Include hello.h. Okay, it sees hello.h is include. I have this file here. It will copy line from 1 to 21. Okay, simply just copy the whole thing, paste it here. Basically, it replaces this line with those. Done. Fine. Next is sees let all these comments ignore. If it sees comments, it ignores them. It sees main function. Oh, great. I've detected main function. Then it sees scope. Okay, so it knows I have to separate out scope. Main also has its scope. Yes, yes, yes. Then it sees integer a. Okay, so it will define a hello. You'll try to see if it finds hello. It's not there in this file. Okay, is it there? What I have pasted already? Hello.h. Yes, I found it. So great. This function call, I won't throw any error. Custom hello. Okay, I will look for a hello in custom namespace. Is there a custom namespace here? Probably in the copy pasted file. Let's see. Yes, custom namespace has hello. Great. I'll use this function. Fine, great. Now this scope itself ends. Okay, great. Comment, ignore. See out inside custom namespace. Yes, I got it. Now standard see out. Where is it? Is it inside the iostream whole file that I have just pasted? Yes, it exists. Okay, then this line ends. Everything is commented. Ignore, ignore, ignore. Compiler ignores everything. Then sees return hello. Okay, fine. Now this was the first step. Okay. The first step, okay, there's actually two steps. First step is include everything. Okay, these are called preprocessors. So that happens before anything happens. That's the first step that happens. Then it tries to compile after the preprocessor. It tries to compile things like what I was doing line by line. Okay, to see the integrity of the code. Okay, once that is checked and everything, it sees all the functions that it can call. Everything is uh, nice and clean. Okay, next comes the compilation, where it translates all this code to assembly language. Okay, so essentially that means there is I don't know how to show it yet, but you can sort of like Google things also. But essentially, it's like moving, let's say, this variable to some register or so on and so forth. Instructions like that. So these instructions are very, 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 very machine specific in the sense you can only, let's say, use the x86 instruction in x86, or if it's supported in x64, you can use that. You can't use ARM instructions there. You can't use x86 instructions in ARM, or sys architectures in RISC, so on and so forth, because those are very, very specific to the CPU. Those are the instructions I'm talking about. That gets translated for each of these lines. Next, they get converted into machine language, which is zeros and ones. Okay, that comes at the last step. That is essentially what this guy is. Okay, so there are different object files. So those are the object files I'm talking about. You can make them in between, but essentially what happens is they get combined, and finally we are just interested in the final machine binary. So this out file, or in this case actually not the dot out, just here the hello.out, that compiled binary has only zeros and ones. So that was the answer to actually what you see in binaries. End of the day, every binary, even G++ here, okay, our compiler is just made up of zeros and ones. Okay. It has no information of instructions and everything. You can, I mean, there is this idea that you can disassemble things and try to read what kind of instructions are there. So what could be the code and all that. Yes, people do. I mean, one can do it. There are people who do it, but the point being, this piece of English written text, okay, which is a C++ code, gets translated into assembly language and then to machine language, the zeros and ones. There are more steps to it. Okay. So like here, when I'm building this, I can make a static build. So a static build means I'm including all the headers inside the binary. Okay. A dynamic build means I'm including them, yes, but the actual functions, let's say here, the whole function, I might be just linking it dynamically. Okay. As in, I'll just link the path and it will just read it from some other path. So let's say this definition exists in some other path. I'll just include its, so like IOStream here, it's there, let's say in some path, right? So that definition exists in IOStream, but the actual definition, as in the actual body, okay? So let's say the couts we call, it will just have something like this. But it will look like, think of it this way without the body. We'll have cout, open and end. That's it. The actual body will be compiled into something called an object file, which ends with .o or .so or so on. They will be there in some other place. You link to them while compilation. So for example, you can have something like this, hello.cpp or hello. This is an example. So hello.o, then it will be, let's say, iostream.o and so on and so forth. Okay. So all these object files get combined while making the final binary. Okay, so which you run. Now this object file could be there in other place. All right, that's called a dynamic linking. Or you can make a static build and include all the things inside your library. So that's what happens when you have static builds. You can, because it has all the information in itself, that is more portable. But dynamically linked libraries are not, because obviously you can't have that same path in other places, right? It depends how you want to write codes and so on and so forth. Yeah, that's the idea. Okay. Benefit of creating a header file. Yes, keeps things clean. That's essentially it. I can have just one file with all my code. Yes, but development becomes very difficult, and honestly, it's not needed. The other good part is, think of it this way. I can compile, let's say, vector.cpp's body once. And because I know whatever, let's say, this hello.h has, let's say in my namespace, cout, hello, add, so on and so forth. I can create, actually, this is, okay. There's a better way of explaining. Okay. Let me call mm, this as main.cpp. So usually this is how codes are written. So we have a main.cpp. I'll include hello.h. Okay. Now hello.h will only have the function declarations like cout, uh, hello, add. That's it. Okay. And this also will just have hello. The actual body and this whole function will just be there inside hello.cpp. Now I will uncome, basically have the body. Now, what I did is, let's say I'll compile hello.cpp and make some changes here. I can just recompile this once. Okay. And main.h will have main. Okay. And let's say I don't have integer main here. Completely okay. Completely commented. Okay. And then this body is inside here. The good thing about this is uh, hello.h gives me the definitions that this function exists. Okay. I can call those functions inside main.cpp, which has main. Hello exists. Yes, hello exists. Custom namespace hello exists. Yes, custom namespace hello exists. But what does it do? Okay. Actually, this I think brackets one can ignore. But anyway, the point being, yeah, actually one writes it this way. I think this is as far as I recall. Yeah. You just this is the syntax for it. So, yeah, that should. Okay. So now this header file tells me while including here, these functions exist. Okay. Their actual definition is inside another file. The usefulness is that let's say main.cpp doesn't just include hello.h. It includes several other functions. Let's say another header file with function one, not function one, file one, file two, file three. So each of these file have header files. It shows the underscore because it doesn't exist. But for the example, assume that these exist now. Okay. Now, if I make a change in hello.h and include everything in one file, I have to recompile it again and again. But let's say I just make changes in hello.h. Okay. I don't need to worry about recompiling file 1 to 3 because it's already compiled, it doesn't change. Since I've included its header file, I know those definitions exist in this header file and the actual body exists in the object file, which I'm already linking anyway. So you just have to compile G plus, sorry, G plus plus output, let's say hello.h, this everything. Instead of main.cpp, first you make, you compile into some object, let's say main.o. You can just include file.o, sorry, the one, file.2, so on and so forth. And all this system is part of the build system like CMake and make. Again, they take care of a lot of this file handling like build tools. But the point being, let's say we want to just use C++, then you can just sorry, this one will be this way. You can compile only one guy at once and then link it. That's the essential idea. You don't have to recompile everything together. It makes building very fast. That's the beauty about this. When you segregate things, it makes building fast. Okay. Yes, that's the answer. But again, I understand I went a little off topic here, but this is essentially how C++ works. You divide into chunks, okay? And then you can compile each part separately and then combine it together. And whenever only one part changes, it only needs to recompile only that part and just link it again. Okay. All right. Any more questions? This one, I think I just leave it. Yeah, coming back to what is it? Oh, yes. Yeah. Yeah, coming back to the code again. I'll try to cover vectors again, so that well, the motive was to cover more things, but anyway, that's okay. We can cover them next class. Uh, yes, so custom namespace adds the functions. Return to C, that's what we printed. Okay, so we saw last class. Another important thing about C++ or C in general is writing if statements and for loops. Okay, there is more or less um, every logic you can sort of think in these two terms. So what are these? So technically, even for loop has an if statement, but we'll come to that. So for loop, you start with the initializer. So we're saying we're declaring integer I, okay, setting it to 0. That's what this line does. Then this is the if condition. If it is less than 5, then you continue. Okay, so that's the body. It runs this, executes this code. Once this loop ends, it executes this part. It increments it. Okay, this I plus plus means it increments I with 1. I equals to I plus 1. Checks the uh, condition, runs the array. If it is true, it runs it again, so on and so forth. So the loop keeps running until this condition is satisfied, until it is true. As soon as it is false, the loop ends. Simple stuff. That's the for loop. And small difference between I plus plus, I'll come to that. Okay. And yeah, you can set, let's say, A to 5, B to be using brackets. You can even do custom addition. The nice thing about this is this will evaluate in compile time. Okay, so B will get set as long as it's a valid code. So you can put brackets and everything, write expressions. Okay, this way. This is some inbuilt data types. Int. Another inbuilt data type is Boolean. Okay, basically stores true or false. Basically, it's just 1 bit. Okay, and we are saying D equals this expression. So equal double equal to means it compares. So is 5 equal to 3? No. So it will store return false and store it in D. Seeing some if statements. So if B is true, then the first line gets executed. If it is false, then the second line. Okay. The code here will not run first one because D is false. So it will run the second one. Okay. I hope that is clear. Another operator which also is used is the ternary operator. Now, what is that? So the ternary operator is this question mark. Okay. So let's break this line 60 first. So we're storing E equals to something. Okay. Like this rest of the code. Now let's look at what this is. So the first bracket, if you see, there is a sorry. So there is a custom namespace add function. Okay. Takes 5 and 7. Basically, then what we'll see is add function. Let's go to that. It takes a b, returns a plus b. Okay, so it adds two numbers. So 5 and 7, it adds two numbers and then returns here. So this part is basically 12. Okay, compares with 12. So, and there is a return there. So the answer is true because 12 is 12. So ternary operator, there is a true clause and there is after the colon, there is a false clause. The first part gets executed if the expression to the left of question mark is true. So it will return 10. If the left was false, so let's say I make it 13 or 14 something, then it will return 12, which gets stored in E. So the value that gets stored in E is either 10 or 12, depending on the evaluation of this expression by the ternary operator. Okay. I hope this is clear. Again, some prints to see the same thing. Then J is 0. Okay, that's oh yeah. So this is to explain some expression. So for example, I define J as 0 and print it. I hope everybody is clear that we print 0 here. Now let's store because I had defined A and B already, I can reuse them. So A equals to J plus plus is one thing I'll store, okay, and B as plus plus J. So last plus one person I think asked, why do we write I plus plus or plus plus I? Okay. For the for loop, it makes no difference. Okay. But one should be careful with the use case and what does it entail. Okay. Let's run this now. Load at image is here. Okay. I don't need to worry about it. Mm, yeah, I think that should be okay. Good to go. Okay. No, no, no. Uh, Yeah, so there'll be a lot of prints that we'll see. One is this is the loop part, okay, that we saw. Then there'll be some part. Okay, that's all this time. All these things are fine. Let's focus on the J actually. Okay. So when it prints J first time, so that is 0. I hope that is clear because we just set it and printed. When we do B equals to plus plus J and try to print B and J, okay. So J gets incremented. That is the increment operator. Plus plus, if you see both sides, that is the um, action on J always. That means it means J equal to J plus 1. Okay. So J gets plus 1. What B gets is the value of J after the increment. That is the return. So basically what I'm trying to say is J plus plus and plus plus J only differ with the return type. Okay. Both do the same thing on J as in increment J to plus 1. Okay. But if you print A, now we printed B, which gave us 1 because J was already 0. Okay. So it gives the value after the increment. Let's now print A. A0. J plus plus returns the value before the increment, as in the original value of J. Now, if we're coming back to the loop, yeah, coming back to the loop, for I here, there is no need for return. It's just an increment. So I will get incremented if you use I plus plus or plus plus I. Either way, it will return something, but that return is not captured anywhere. So it doesn't matter. For the loop, it makes no difference. Okay. You can choose to write I plus plus I. It's just personal bias. I like writing I plus plus. Okay. Any questions? Okay. All right. Moving on. So this and this, I guess we can just ignore. Yeah. Yeah. Okay. Now let's look at a very, very, very important data structure representation of it in C++. That's the vector class, which represents the list data structure. List is basically a collection of certain data type. Okay. In C++, let's say you want to use standard vector. Okay. It enforces that all the collection of data is contiguous in layout. Okay. And is of the same data type. These two are very important things. Okay. And C++ enforces that. How? Now, while declaring your standard vector, you use something like namespace standard. Okay. Call the vector. And here vector is a class actually. We'll learn about classes and objects, but vector is a class here, a templated class. Okay. We'll learn about templates. But essentially you can for now think like integer is the inbuilt data type it takes to say that whatever the collection it has is of that data type only. Okay. So integers, if let's say I want a collection of integers. Okay. So I'll pass integer here. A is the object of that vector class. Okay. Or for now you can think of like that's the variable name I'm giving to the vector. Okay. So A is the vector for me. And if I use brackets, and pass some value, okay, like 5 here, it means that is the size of the vector that I am declaring. And I'm telling to the OS or computer, you can think like any way you want. I'm telling the OS, allocate 5 integers for me to use. You can declare in many ways the vector. You can do it this way also. Define something integer called size, okay, and pass that size here. You can do that. So that is absolutely okay. You can have 5 or you can declare nothing. So when you pass nothing here, it becomes an empty vector. The code knows that there is a vector called A, but it doesn't have any size. It doesn't know anything. It can't store anything also. That's the beauty about vector specifically. You can resize it later. Okay. Now resizing it, what it does is it changes the size to 10. Now, let's say you already had declared it to have size 5. You want to declare it to size 10. Remember, from performance perspective, this is an expensive operation because sometimes you might not have the, so think of this, a list, or let's say this is a collection of integers. It stores 1, 2, 3, 4, 5. Okay. The next set of data, sorry, it wants to store, okay, this should be available in the memory of actual memory of the system. If it's not, okay, it has to deallocate the whole thing, move to a different memory location where it can have 10 values. And as you can think, obviously, this is an expensive operation. So usually avoid resizing vectors. It's better to have a certain size, maybe a larger size, declared and allocated once and just reused multiple times. Just from performance perspective, okay, just so you know. Now you can resize a vector to like literally any large number, technically speaking. But do remember, these vectors get allocated on your RAM, okay, or the memory, yeah, on the memory of your system. If it doesn't support that much values, it can't, let's say, then you're going to have trouble. Okay. Now, two concepts about vectors. One is the size and the other is the capacity. Size is the vector current size. As in, so for example, in this line 7, the size of the vector is 15 because that was what was defined. In this line, it will be 5. In this line, it will be 0 because we did not note in its size. Capacity is a little higher than that, as in whenever you allocate a vector, your OS, okay, will allocate, let's say, 5 values for you to access. But the actual storage your vector text need not be 5. It will be more than that, like equal to 5 or more than that. Now, why does it do that? So that sometimes, let's say you want to resize something and let's say it takes only 5 values here for now, you can access. It's, let's say it takes already 10, like it has already allocated. Then it becomes easier for it. Okay. So that's what the capacity does. It's the memory that the vector takes, but you can't access it because ideally you have defined your size to be 5. So anyway, you can't access it yet, as in it will be out of bounds access, okay, for your vector if you try to access outside the size. But if needed, you can resize it later, okay, to that capacity size. And in a way, you won't be hit with a performance penalty in a way. So that's the idea with the capacity function. Another thing is to access, access functions, we have to use the dot operator. Like, okay, so that dot is always with conjunction to the object here. Okay, again, we're not covered objects and classes, but A is an object here or the name of the vector, and it has some member functions. It has certain uh, member functions like that are defined inside the vector class. Okay, so you can access them uh, specifically. So like vector named A has its own size. A vector named B will have its own size, capacity, and so on and so forth. Okay. The size function keeps detail of the size of the vector current. Okay. How much values it can store. Capacities, actual storage it takes in the memory, which have not yet been allocated yet. As in, it has been allocated, but you can't still access it. And to access a vector, you can write a for loop. Okay. Use the big bracket operator. Oh yeah, I'll cover member functions and so on. So when we learn about object-oriented programming, classes and functions, classes and objects, I'll talk about member functions. For now, you can sort of ignore it if you don't know, but just to you can keep it in the back of your mind that these are objects and these are the member functions that we call. In any case, that's fine. But the idea being vectors have different functions you can call, okay? Like the resize function, size function, capacity, so on and so forth. Okay. Another useful function they have is the bracket operator. Okay. So this is to access an ith element, you use the brackets. Let's say I write it to I and then print. So a dot size will print to size 10 here, okay, because I've resized it. If it was 5, but I resized to 10, it will print from 0 to 9. Okay, you can actually see that. That happened. Yeah, segmentation fault is good, but resize should have happened only for 15.
The second one.
Sorry? Oh, yes, yes. I think I have resized that. No, wait, that is fine. Um, this is which file I have. This is this. I have the vector.cpp, which is fine. Oh, syntax. Okay.
Bottom loop. You have written wrongly.
This one.
I condition.
Uh, which one are you saying? Oh, yes, there is no condition here. Correct. Thanks for that. Let's ignore this part for now. I'll come to it. Yeah, okay, great. Yeah, basically the IS. Oh, yeah, that's actually a good example. Because we did not give any exit condition, it kept incrementing I, okay, and started printing stuff. Okay. Until it reached some place. Okay, we did see a segmentation fault. Oh. I don't think. Okay, it will hang. Sorry, my bad. Delete. It find. No, it is too big. Yeah, okay, great. Found it. So once it reached a certain line, okay, after that it just gave up. Because anyway, if you think about it, we only asked for like 5 integers, but started accessing values much larger than that. So that is one important um, bug, if you can say, I mean, it's definitely a bug. It's a very important bug that usually one encounters in lists when you access out of bound memory. That's the segmentation fault. Okay. All right. So one thing to note here is accessing out of bounds is very easy in C++. There is no check. Okay. So the way this bracket operator works is you just tell um, the vector, give me the ith element. Okay, I'm accessing it, I'm storing some data there, or I'm printing it out, something like that. Now, that value, that place might be much larger than what you have actually asked for. Hence the error. Okay. All right. This is yeah. So now if I have the size 10, so here's capacity is also 10. It prints, okay, and then prints till 9. Now here comes the interesting part. So if you look at the second loop, it's essentially the same as the first loop here. How is that? Like why? Now remember, this bracket operation is essentially a overloaded function. As in, this is also a function which returns something, and that something is basically this. Now, what is that? I'll cover pointers maybe in more detail in the next class. Actually, that was the next topic. Anyway, I'll just give a brief for pointers now. So a dot data, okay, is again a member function of the vector class. Okay, so similar to how resize, size, capacity, everything works. There's another useful function in vectors. It's a dot data. So data returns the pointer to the initial part of the array list. So you have, let's say 1, 2, 3, 4, 5, 6, so on, right? So the pointer to the first value is inside a dot data. Okay. Now we'll do some pointer arithmetic here. So a dot data is the first pointer, as in it's the first number. Okay, so think of it pointers as just addresses. Okay, these addresses are also numbers. Think of it like 64-bit integers. Okay, so think of a dot data as some integer. It might be some large number, let's say 10 million. I'm just throwing some numbers out there, but then each data next to it, okay, you can access you access by just adding I to it. So the zeroth data, which the data itself is, okay, a dot data pointer, that is that position number. The next data will be +1 of that. The next data will be +2, and so on and so forth. Okay. Now, how does it know how much? So in memory, everything is like in units. So this is the unit, right? But what is that unit? It knows that from the data type of that pointer, which will be integer. So in general, integers are 4 bytes. So it knows that I have to move that many units of 4 bytes. Okay, because it knows that the pointer is an integer. Okay, so we increment from that initial location to that position, and then with the star operator, we dereference it. As in, this part accesses the memory location, more specifically the ith memory location from the initial point. Dereference operator accesses the value at that point. Okay, and then finally, after accessing the value at that point, we just equal to I, as in set the value to that I or whatever you want. This whole thing is equivalent to writing this. So when you actually write the bracket operation, this is what actually takes place. It's a pointer arithmetic. It's essentially what happens. You access the actual location, dereference it, and store the value, or print the value, or whatever. I can actually do it this way. Yeah. And then let's comment this, and yeah, press exactly the same thing. Okay, from 0 to 9. Okay. I guess that more or less covers again the recap of past class. But anyway, I hope the two whatever concepts we covered today are clear with all the namespaces, scopes, functions, standard tuple library, basic operations, again, loops like for loops, the if statements, ternary operator, the difference between the incremental, so like plus plus j or j plus plus, and the vector class itself. Okay. I'll try to cover pointers a little more. Again, a very important concept again, and also sometimes it gets very confusing with in C and C++ are the pointers, the concept of pointers. I'll cover them in more detail. But I hope the topics that I covered today are clear. And yeah, if you have any questions, feel free to ask. And yeah, next class also you can come with your doubts, and we'll cover pointers and let me see what are the topics. Yeah, pointers. I was going to cover scopes also next class, but well, today. But anyway, I covered that. We'll cover arrays, const, keywords, details about heap and yeah, heap and stack. Yeah. Okay. Yeah. With that, we can end today's class, and I hope it was enjoyable. And do practice. That will be my suggestion. Again, you can build projects also, but if you want to have, let's say you learn a lot of topics in C++ and you want to put it to use, project building is a very good idea. But if you want to learn certain topics itself, I would say start with some basic um, codes first. Yeah, that will be all. All right. Can end today's class and see you guys next week. Happy coding. Thank you. Thank you. Yes. Thank you. Thank you.